Okay, so this time what we're going to discuss is about forecasting, no? So many operations managers struggle with combating inaccurate production forecasts and coming up with an adequate plan to combat inventory levels. So this is why uh, utilizing the appropriate and most accurate forecasting method is by far one of the most substantial components within many manufacturing operation, because forecasting pertains to utilizing several different methods of estimating to determine possible future outcomes for the business. So to give us more details about the topic, let us all welcome our presenter. Go ahead, sir.
Thank you, sir. Am I audible po?
Yes, sir. Yes, sir.
Okay po. Sige po. Good afternoon, Dean and classmates. Here I am again, RG Malandog. And now I will discuss Chapter 3 of Advanced Production and Operation Management, which is workload assessment or forecasting. So forecasting is an estimate of demand which will happen in the future. Forecasting is not the term generally used to talk about the composition of a random draw of cards or how a roulette wheel performs. Those are statistic phenomena for which probabilities are known. And forecasting is to foretell sales, demand volume, even though the probabilities have never been formally studied. Business people often use their sense of what is happening to reach decisions that might be better made if someone had kept a record of what had taken place already. So since it is only an estimate based on the past demand, proper care must be taken while estimating it. So given the sales forecast, the factory capacity, the aggregate inventory levels, and size of the workforce, so the manager must decide at what rate of production to operate the plant over an intermediate planning horizon. So the focus here is on using existing data to develop forecasts. So mathematical equations are used for various kinds of forecasting. It is important to stress that equations do not make forecasts the truth. Also, a great deal of good forecasting can be done without mathematics. So further, with or without mathematics, no forecast is ever guaranteed. So time series and extrapolation. So time series is a stream of data that represents the past measurements. So each event or observation of demand is time tagged so that it is known where it is located in the series of data. So the time series consists of data recorded at different time periods such as weekly, daily, for the variable which could be units produced or demands received. So time in time series analysis, external causes are not brought into the picture. So the patterns of the series is considered to be time dependent. So the data in time series may consist of several different kinds of variations. So important among them are random variation, an increasing or decreasing trend, and seasonal variation. So in random variations, it occurs because the demand is seldom constant at a given level. Gaya ng example here sa graph. So the random variations are a result of the economic environment and the marketplace within which an organization is operating. So in addition to random variations, the time series data may exhibit an increasing or decreasing trend. So here, the graph on the left shows an increasing trend, while the graph on the right shows a decreasing trend. So in such cases, it is possible to extrapolate the curve by eye, but the rate of change can also be calculated and projections can be made mathematically. So in mathematics, extrapolation is the extension of a graph, a curve, or range of values by inferring calculated inferring unknown values from trends in the known data. So sa my example graph natin, if we extrapolate the graph, since etong nasa left, yung left graph has an increasing trend, we can extrapolate it na increasing din yung trend. So kung i-extend natin tong graph na to, ang trend natin is increasing as well. On the other hand, yung decreasing trend naman, if we extrapolate it, pag in-extend natin tong graph, it will be in a decreasing trend. So the time series may also exhibit seasonal or cyclical variations. So the graph on the left shows seasonal variations coupled with random variations, whereas the graph on the right combines all three components, yung random variations, increasing trend, and seasonal variation. So example ng seasonal variation is yung mga business ng resorts and hotels, yung na may mga seasonal peak. So yun yung example ng seasonal variations. So time series analysis is analysis of any variable classified by time in which the values of the variable are functions of the time period. So sa time series data can be reflect erratic bursts called impulses. So if these spikes appear from time to time and some patterns can be associated with them, they could be added to the list of what can be extrapolated or projected into the future. So time series analysis deals with using knowledge about cycles, trends, and averages to forecast future events. It is always useful to try to find causal links between well-known cycles such as the seasons and the demand patterns that are being tracked. So time series analysis uses statistical methods, including trend and cycle analysis, to predict future values based on the history of sales or whatever the time series describes. So the importance of time series analysis, it actually helps organizations understand the underlying causes of trends or systematic patterns over time. It uses data visualizations. Business users can see seasonal trends and dig deeper into why these trends occur. It is also used to determine a good model that can be used to forecast business metrics such as stock market price, sales, turnovers, and more. It also allows management to understand timely patterns in data and analyze trends in business metrics. So forecasting methods for time analysis. So we will study the following techniques for time series analysis, namely moving average, weighted moving average, exponential smoothing, seasonal forecasting, and trend analysis. So the moving average or MA method supplies a forecast of future values on recent past history. So MA is also called simple MA method. So the latest N consecutive values, which are observations of actual events such as daily, weekly, monthly, or yearly demand, are used in making forecasts. So this data are recorded and must be updated to maintain the most recent N values. So with the passing of each time period, the most recent values is stored and the value of the earliest period is dropped off. So for example, if you want to forecast the demand of April in this example, using N is equals to 3, then the demand for last 3 months, that is January, February, and March, are needed. Kasi nga N is equals to 3. So for the past 3 months yung gagamitin natin for the month of April. So that means it's January, February, and March. So the demands for last 3 months, that is January, February, and March. So the forecast for April can be calculated as this one. Yung demand 1, which is yung kay January, demand 2, which is yung kay February, and the demand 3, which is for March, all over 3, which is yun yung N natin. So yung demand forecast for April will be 90, as you can see here sa calculations. So kung kukunin mo naman yung mga succeeding months with N equals to 3, ganun lang din. Kung kay May, ang gagamitin natin is April, March, and February. Ito po siya, as you can see with the in the calculations on the table. So ayan po. And so moving average might be used to extrapolate next events if the following occurs. There is no discernible cyclical pattern, and the system appears to be generating a series of values such that the last set of values provides the best estimate of what will be the next value. So for weighted moving average naman, it's similar to moving average, but it has a weight. So a way to make forecasts more responsive to the most recent actual occurrences or the demand is to use the weighted moving average or the WMA method. So just like the MA method, the most recent end period is used in forecasting. However, in this method, each period is assigned a weight between 0 to 1. So the total of all weights adds up to 1, and the highest weight is assigned to the most recent period, and then the weights are assigned to the previous periods in the descending order of magnitude. So for example, n is equals to, for example, let's consider the data given in this table. So suppose that the number of periods used in forecasting is 3 again, n is equals to 3. And then the weights are 0.2, 0.3, and 0.5 respectively. So the highest weight in this case is 0.5. So 0.5 will be assigned to the most recent period. So for example, the forecast for period 4, which is April, let's say yan si period 4, will be calculated by using the weight 0.5 for period 3, which is the most recent. And then descending order siya. So since si 0.3 na yung susunod na mas malaki kay 0.5, siya yung gagamitin nating weight sa period 2 and then so on. So ito po yung example sa calculation niya. 0. So para makuha natin yung forecast kay month 4, tinimes lang natin yung weight. Kinuha lang natin yung average, yung weighted moving average niya by multiplying yung mga sales forecast ng mga yung past 3 months and then weighted lang siya. So yung pinakamalaking magnitude again will be used sa most recent end period and descending in a descending order. So the WMA method allows the latest period to have the greatest impact and later periods decreasing importance. So note that when all weights are equal to 1, so the WMA is the same as MA. So technically, pag ito is pare-parehas, itong weights ng N ay pare-parehas, yung weight niya, pag kinumpute natin yung forecast ng mga succeeding months is parehas lang ang lalabas kung gagamitin natin yung MA method. So kailangan talaga mas nabibigyan ng importansya yung most recent N period, kaya mas malaki yung magnitude niya kung gagamitan natin ng weighted moving average. So the biggest weight are assigned to the most recent events when there is a continuing trend. So next will be exponential smoothing. So the exponential smoothing or ES method, like the WMA method, calculates an average demand forecast. ES methodology remembers the last estimate of the average value of demand and combines it with the most recent observed actual value to form a new estimate average. So ES forecast the demands for a given period T by combining the forecast of the period T minus 1 and the actual demand of the previous period T minus 1. So the actual demand for the previous period is given a weight of alpha, and the forecast of the period is given a weight of 1 minus alpha, where alpha is a smoothing constant, so whose values lies between 0 and 1. So the equation for the forecast for period T is this one. So forecast T is equal to forecast T minus 1 plus alpha times the difference of actual demand T minus 1 minus forecast T minus 1, wherein alpha is greater than or equal to 0 but less than or equal to 1. So for example, consider the data given in this table. The ES method make a forecast starting from period 2. So the forecast for the first period is generally set equal to the actual demand in that period to get the forecast process started. So forecast for all period 2 to 10 are given in this table as you can see. Ito po yung forecast niya. So ES is a simpler method requiring fewer calculations than WMA, which need n weights and n periods of data for each forecast estimate. ES, or the exponential smoothing, needs only 3 pieces of data. Also, it can be more effective because only one weight, alpha, which is alpha, has to be chosen. So this make it easier to experiment with past data to see which value of alpha provides the least forecast errors. Often, the use of the ES method for forecasting is preferred to the WMA method. So again, the ES method has a clear advantage over the MA method in terms of the amount of memory required for storing the data. Unlike sa MA method, kailangan mo pa yung mga past information or data mo para makalculate lang yung demand or yung forecast using MA and WMA method. On the other hand, sa exponential smoothing, tatlong data lang ang kailangan mo para ma-compute mo yung forecast. So for the MA method, actual demands for the end period have to be stored. Unlike here sa exponential smoothing, hindi mo na kailangan i-store pa yung mga previous data. Next will be forecasting with a seasonal style, or seasonal forecasting. So forecasting when seasonality is present can be done by assuming that what happened last year or last month or etc. will happen again. So we call it the historical forecast method. So the pattern is expected to repeat itself within the time period. So this method works if a stable pattern, which is often seasonal, exists. So example of this will be the hotel and resort business. They are typically involved with historical forecasts, as well as yung mga agricultural businesses. So when last year's month sales value are used to predict the next year's monthly sales values. So the method is based on using past history to forecast. So the same concept applies to weekly or daily sales, which can be forecast on a semi-annual, quarterly, or monthly basis. So it shows in this table, ito po, the historical forecast technique applies to data that exhibits a seasonal cycle. So no modification has been made for an overall change in annual sales, which is the basis of the historical forecast. So as you can see po dito sa example sa table, your actual sales last year will be the same as the forecasted sale next year. So ayan po yung seasonal forecasting. So consider the data in this table that gives the quarterly demand for last 4 years. So this clear pattern of demand variation among the 4 quarters based on the data, we can forecast the demand for the 4 quarters of year 5. Ito po yung example. Yung assume that the year 2021, the quarterly demands were 10, 30, 20, and 40. That gives our yearly demand of 100 units. So further, let's assume that in 2022, the yearly demand is expected to increase to 120 units. Then the quarterly forecast would be adjusted. So as you can see, yung quarterly demand became 12 instead of 10 since tumaas nga yung units natin for the year of 2022 and so on. So 36. So technically, 10% ng expected 120 units, plus 30%, 20%, and 48%. Same with year 2023. If we assume that the pattern continues and the base level increase to 150, all you need to do is to get the 10%, 30%, and 20% and 40% of 150 for you to get the quarterly demand, which is 15, 45, 30, and 60 respectively. Okay, so ayan po, consider the data in this table that gives quarterly demand for last 4 years. So here's an example. I just use yung 4 seasons to represent the quarter of the year: fall, winter, spring, and summer. So based on this data, we can forecast the demand for the 4 quarters of year 5. So assume that the annual demand is expected to be 2,800 in year 5. this demand has to be estimated using other techniques. So the following 5 steps will be used to obtain the quarterly demand. So step 1, so find average quarterly demand for each year. So the total demand for each year is divided by 4. So number of quarters in each year to obtain the average demand in each year. So the table gives the average demand for each quarter. As you can see, ito po yung average niya. So kunuha lang yung summation niya and then divided to 4 kasi nga 4 yung observation natin. So pinag-add lang po yung 4 so you can get the average. Ito po yung calculation niya, summation ng 4 and then divide by 4. Then step 2, compute seasonal index or SI for each quarter for each year. So the seasonal index for a quarter for a given year is obtained by dividing the demand in that quarter by the average quarterly demand for that year. For example, the seasonal index for the winter quarter of year 2 is 1.09, which is obtained by dividing 2,420 by 2,221, which is the average quarterly demand for year 2. So the seasonal indices for each quarter of each year are given in this table. As you can see, ito po yung mga seasonal indices niya. So the formula to calculate the seasonal indices is also given in the table. Ito po. So yung quarterly demand niya, i-divide lang natin siya sa average quarterly demand para makuha natin yung seasonal index niya. Quarterly demand over average quarterly demand. Okay, so step 3, calculate the average seasonal index for each quarter. So the next step is to find the average seasonal index for each quarter, which is simply the average of the seasonal indices calculated in step 2, yung previous step natin. So this table gives the average seasonal indices for each quarter. So for example, ito yung mga seasonal indices ng fall for year 1, year 2, year 3, and year 4. And then, kinuha lang natin summation niya and then divide by 4 to get the average. Ito po yung average SI ng fall and the winter, spring, and summer. So same lang siya, kunin lang natin summation ng all average, all seasonal indices, so to speak, divide by 4 so we can get the average. So step 4, calculate the average quarterly demand for next year. So in this step, we find the average quarterly demand for the next year. So the yearly demand estimate for next year is again 2,800. So therefore, the average quarterly demand will just simply be 2,800 divided by 4, which will give us the figure of 700 as shown in this formula. So kanina, yung inassume natin na demand for year 5 is 2,800. So in order for us to get the average demand per quarter for year 5, all we need to do is divide this by 4. So we can get the average demand per quarter. So step 5, forecast demand for quarters forecast demand for quarters of next year. So the quarterly demand for each quarter of next year is obtained by multiplying the average demand by the seasonal index for each quarter. So the table gives the forecast of the quarterly demand of next year. For example, yung forecast for the spring quarter is 638 kasi yung average quarterly demand natin is 700, then minultiply lang natin siya sa average seasonal index for spring. So nakuha na natin yung quarterly demand for spring sa year 5. So yun lang siya. So basically, it's just the average demand for year 5 times the average seasonal index for each quarter para makuha natin yung demand for quarterly demand ng year 5. So in our example, we have used year as the time period in which the seasons are represented by quarters. So the season could have been represented by months if the times here shows variation by month. In some instances, the week could be the time period as well, And the days could be the seasons if the demand fluctuates on a daily basis. So business example for a daily basis fluctuations are the restaurants where the demand fluctuates on a daily basis. So even hour of the day can be the season. Ang example naman ng hour fluctuation is yung mga telephone, yung mga BPO or mga telephone company wherein their demand vary on an hourly basis. So trend analysis. If the time series exhibits an increasing or decreasing trend, then the techniques discussed above, which the techniques that we have discussed, which is the MA, WMA, and ES, may not be appropriate for making a forecast. So we perform a trend analysis to make a forecast in this case. Consider this graph. The zigzag shows the demand for 10 periods. So there is clearly an increasing trend, as you can see. So the trend analysis will fit a trend line through this data to make forecasts. And the equation of the trend line is y is equal to a plus bx. If you can recall, itong formula na to is inintroduce sa atin during our algebra days. I think ito yung after introduce yung integers and Cartesian plane, yung quadrant 1, 2, 3, 4. Ang next topic nun sa algebra is linear equation. So pag nag-linear equation kayo, magiging familiar kayo sa formula na to, which is the slope-intercept form. Wherein, where y is the demand forecast and x is at the time period. So, dito, in this trend line equation, A is the intercept on the y-axis, which is the value of the demand variable y when x is 0. So technically, if we substitute x with 0, then technically CA ang matitira, y is equals to A, which means the CA is the y-intercept in algebra, wherein x is 0. So siya yung makikita nyong point sa y-axis kasi 0 si x. So the slope of the line is represented by B, which gives the change in the values of demand variable y for a unit change in the values of x. That is, B is the amount by which demand will change if the time period changed by 1. So again, sa algebra natin, slope B is rise over run. So yun yung parang yung tinakbo nung graph. So ayan, so there are mathematical formulas for finding the values of A and B. Ito sa reference na ginamit ko, ang given values lang will be the values of x and the values of y. So in order for us to get the value of slope and intercept, we will be needing to use this formula wherein intercept is equals to the summation of y times the summation of x squared minus summation of x and times the summation of x and y all over n times summation of x squared minus summation of x squared of summation of x, so to speak. So sa reference na ginamit ko, hindi na pinakita kung paano siya kinompute. So pakita ko na lang, I made a computation beforehand. Pakita ko na lang din muna. Ay po, nakikita po yung screen?
Yes po.
Ayan. So ito po, I calculated the slope and the intercept beforehand. So in order for us to compute the slope and intercept using the long method, etong formula na to, all we need to do, since ang given values lang natin is the values of x and y's, we will be needing to get the values of xy, the values of x squared, and the values of y squared, as well as the summation of this data. And then itatranspose tatranspose lang natin siya sa formula at ito siya yung makukuha natin. Ito yung sa long method. Ngayon kung may oras kayo i-compute, ito po yung lalabas niya. So si y-intercept is 2.73 and then si slope is 8.64. Now, sa Excel, may built-in function siya to find the value of A and B. So para mapadali yung trabaho natin, para maiwasan din natin tong long method na to, yung para compute yung xy, x squared, y squared, and then the summation, we can actually use a shortcut sa Excel. Pakita ko na lang din. So first, punta ka lang sa formula, so more function, then search nyo lang yung intercept. Here, as you can see, nandito na siya kasi ito yung most recent use ko. Search nyo lang yung intercept and slope. So ito na lang. So for you to get the value of intercept in the easiest way, all you have to do is to highlight all the values of y. And then here, i-highlight din natin yung all the values of x. Pero may values pa ba si x? Wala nang value si x, di ba? Hindi. Sige. Ayan. So ito sa shortcut sa Excel, as you can see, parehas lang yung value na lumabas, 2.73. So rounded off to the nearest hundreds decimal places, so it will just give you 2.73. And sa slope naman, in order to get the slope, same process. Punta lang kayo sa formula. Then search nyo lang si slope. And then known y's, highlight nyo lang ulit yung all values of y's. And then yung all values of x. Tapos okay. And then lalabas na yung sagot. So ayan, so napadali na yung trabaho natin. Na-skip na natin yung long method using Excel. So, balik tayo sa presentation. Stop share ko lang. So ayan. So here sa example, so since nakuha na natin yung value ng slope and intercept, so the forecast can now be made for any period using these numbers. So for example, using the slope intercept formula, y is equal to a plus bx. So the forecast for period 11, let's say ang kukunin natin is yung time period ni 11. So f of 11 is equal to 2.73, which is the intercept, plus x, which is 11, times the slope, 8.65. So ang magiging value ni y is 97.67. So similarly, the forecast for period 12 will be, yun lang, ulit, gagamitin lang natin ulit yung slope intercept form or formula para makuha natin yung demand ni y. So ito siya, kung sa time period is 12, so magiging y natin is 106.52. So another valuable method that assists forecasting is regression analysis. So this method is used for establishing a relationship between two sets of numbers that are time series. So for example, when a series of y numbers, such as the monthly sales of a camera over a period of years, is casually connected with a series of x numbers, which is the monthly advertising budget, then it is beneficial to establish a relationship between x and y in order to forecast y. So the first assumption that is generally made in regression analysis is that the relationship between the correlated pairs is linear. So example, consider the data given in this table. Ito po, itong data na to. So this table gives 10 observations for the values of x and the corresponding values of y. So the data are plotted in the graph. So we can fit a straight line called the regression line to this data. So the line will be an estimate of the way in which the value of x affects the value of y. So for example, a linear trend is assumed. So once the line is determined, it can be used to extrapolate future demand, which is the value of y. So the equation of regression line is still the slope intercept form, y is equal to a plus bx. So as in trend analysis, a is the intercept, on the y-axis, which is the value of the demand when x is 0. So the slope of the line is represented by b, which gives the change in the values of demand for a unit change in the values of x. So that is b is the amount by which demand will change if the dependent variable change by 1 unit. So dito sa example na to, sa table na to, ang A niya, which is the y-intercept, is 62.44. So ginamit ko lang yung shortcut sa Excel ulit. But if you have time, you can compute for the slope and intercept using the long method. Just get the x and y, x squared, y squared, and then the summation of all datas. Tapos gamitin nyo lang yung formula na pinakita ko kanina to get it. So para mapadali yung trabaho natin, let's use the shortcut sa Excel kasi parehas lang naman ang value na ibibigay. So again, si A, which is the intercept, will be 62.44 given this data, and then the slope will be 50.53. Ayan. So using the slope intercept form, y is equal to a plus bx. Suppose that x is 15, makukuha na natin yung value of y using this formula, using these figures. So 62.44, which is a, plus 50.23 times 15, which is x. It will give us the value of y, which is 815.84. So coefficient of correlation and determination. So an important prerequisite to use regression analysis is the existence of causal relationship between x and y. So therefore, before we even determine the regression equation, it is important to find out whether there exists a relationship between x and y. The scatter diagrams here visually display the relationship between x and y. So scatter diagrams are useful visual aids to find whether there is a relationship between x and y. So this relationship can also be established in quantitative terms by calculating the correlation coefficient. So a correlation coefficient, R, shows the extent of correlation of x and y, where R can take on values from -1 to +1. At -1, x and y are perfectly correlated, going in opposite directions. As x gets large, y gets small, and vice versa. So when r is equal to 0, there is no correlation, and where r is equal to +1, x and y are perfectly correlated, going in the same direction. So it is not only the relationship that exists between x and y before doing the regression analysis, but it is important that a causal relationship also exists between the independent x and the dependent y variable, meaning change in y can be explained due to the change in x. So here, so the coefficient of determination r squared is measured of the variability that is accounted for the regression line for the dependent variable. So the coefficient of determination always falls between 0 and 1. For example, if r is equal to 0.08, then the coefficient of determination r squared will be 0.64, meaning that 64% of the variation of y is due to the variation in x. So the remaining 36 variation in the values of y is due to the other variables. Okay, so forecasting errors. So forecasting errors, it is very rare to get 100% accurate forecast. There are always some errors in forecasting. So a good forecasting techniques tries to minimize the errors. So the forecasting errors are computed by comparing the actual demand for the time period t with the forecast for that same period. That is, error t is equal to demand t minus forecast t. So two kinds of forecasting errors can occur. First, actual demand is greater than the forecast. So this is a forecasting underestimate. By convention, when actual demand is greater than forecast demand, the error term is positive. Second, the actual demand is less than the forecast. So this is a forecasting overestimate. And in this case, the error is negative. So sa forecasting underestimate, the actual demand is greater than the forecast. So magbibigay siya ng error, na positive error, so to speak. And on the other hand, sa forecasting overestimate naman, yung value ni actual demand is less than sa forecast. So magbibigay siya ng negative forecasting error. So to choose a forecasting method, it is necessary to be able to compare the errors that each method generates for particular circumstances. So there are several different ways of measuring errors. The choice is dependent on the situation and what kind of comparison is wanted. Thus, absolute measures are used. Absolute measures are used to count all errors conservatively. So absolute measures means that positive and negative errors are treated the same way. So the reason for doing this is to prevent the positive and negative errors from canceling each other out. So we will study a most commonly used method that calculates mean absolute deviation, or MAD. So to calculate MAD, take the sum of the absolute measures of the errors and divide the sum by the numbers of observation. So MAD treats all errors linearly and is more conservative measure. So example, consider natin tong data sa table. So the demand and forecast are given for 10 periods in column 2 and 3. Ayan. And column 4 gives the error for each period. Ito po. Makikita nyo may positive and negative siya. So may forecasting underestimate and forecasting overestimate. And then sa column 5 gives the absolute error. So the sum of absolute error for 10 periods is 171. Ito kinuha lang natin summation ng absolute errors. So therefore, si MAD or mean absolute deviation will be 17.1. So it was calculated using the summation of all absolute errors divided by n, which is the total number of observations, which is 10. So 17.10 ang magiging mean absolute deviation natin. So in selecting a particular forecasting method, let's say MAS, WMA, or ES, so for ES, we will calculate the values of MAD by using different values of alpha. So the value of alpha that minimizes MAD will be selected. So similarly, applies to MA and WMA method, we will calculate MAD for different values of N. The N that minimize MAD will be selected. Sa weighted moving average naman, we will use WMA method to find the best combination of weights. So kung ano yung magbibigay ng pinakamababang mean absolute deviation, yun yung gagamitin nating forecasting method. Okay? So the Delphi method. So Delphi is a forecasting method that derives on experts' estimations of future events. In one of its forms, the experts submit their opinions to a single individual who is the only one that knows who the participants are and what they have to say. So the person who is Delphi manager combines the opinions into a report, which, while protecting anonymity, is then disseminated to all participants. So the participants are asked whether they wish to reevaluate and alter their previous opinions in the face of the body of opinion of their colleagues. So gradually, the group is supposed to move towards consensus, and if it does not, at the least, a set of different possibilities can be presented to the management. So in a nutshell, Delphi method is like a survey-based framework for estimating the likelihood and outcome of future events. So there is no evidence that the Delphi method provides forecasts and or predictions with smaller errors than other techniques. So it is apparent that the managers gain greater perspective about forces that should be considered when they are contemplating positive outcomes. So yun ang isa sa mga benefit ng using Delphi method. So pulling information and multi-for forecast. So methods for pulling information to provide stronger forecasts should be explored. It is critical that all parties share their forecast as much as possible and try to find ways to combine them. So usually, stronger forecasts can be obtained in both data and experience are pooled. One of the keys to success in combining forecasts is trial and error. So what seems to work is retained and what fails is discarded. As an example of fooling, the results for or the results of a regression analysis could be augmented by a Delphi type estimation. In this way, experience and data analysis might be combined to provide a stronger conclusion. So formal methods can be used to evaluate how well different forecasting techniques are doing. So averaging of forecast results also is used. So the results of taking forecasts from more than one method and averaging this result to predict demand has been successful in circumstances where choosing the best method produces frequent alteration of the chosen method. Ayan. So product life cycle stages and forecasting. So throughout the company, the planning function marches to the drumbeat of product life cycle stages. So operations managers needs to be aware of the timing and stages that drive the development schedules of the new product, goods and services, as well as the product and delivery schedules of the company's matured product. So the product life cycle are composed of 4 stages that appear in a regular way over time. So all products and services go through the following stages: introduction to the market, growth of volume and share, maturation, where maturity is the phase of relative equilibrium, and decline occurs because of deteriorating sales. Decline leads to restaging or withdrawal. So for introduction and growth of the new product, goods and services, there are 2 new products early phase of life cycle stages. These are initial introduction and sales growth of the product. So the idea for the product and its development precedes the introduction. The entire team works on the ascertaining the marketing feasibility of the idea, as well as the feasibility of making it and delivering it. Dito na pumapasok si research and development. R&D may have made sample products so that market research can test its customers' acceptability. When it is approved, so production and operation management and engineering swings into actions to create the product or the production system that can make or assemble the product. So during the process of bringing the idea to reality, there are many make or buy analysis. So maturation and decline of the new products, goods or services. So when the new product is service or service stops growing, it considered mature. This means that its volume is stabilized at the saturation level of the brand. The competitors have divided the market, and the only extraordinary events such as strike at the competitor's plant are able to shift shares and volume. So during the introductory phase, marketing takes specific actions during this phase to maintain the product share of the market. So prices often are lowered, and coordination between production and operation management and sales is essential to meet delivery schedules on time. So finally, the product begins to lose share, volume drops, and depending on the strategy, the product is either restaged or terminated. So meaning the product is already obsolete or phased out. While the demand prediction in life cycle stages provides a classification of, for understanding the kinds of trends that can be expected in demand. So during the introduction, the demand is led by the desire to fill the pipeline. So this means getting products into the stores or into warehouse, or whether it must be supplied in the customers. So this information is fed back through the sales to production and operation management for purposes of production scheduling. So the challenge for production and operation management is the rapidity of adjustment that is required to all the life cycle stage changes, and to go through the frequently, that is plant expansion and contraction. So new supply chain sources, inventory obsolete by immediate demands for new products. Example neto is yung mga mobile phones natin na madaling mag-depreciate, or like yearly may bagong model. So protection of established or matured products, goods and services. So organization that have been successful with their new product introductions can bank on having established products or service that generate cash flow. So the bank is is not as good as it used to be, because the competitive rate of new product introduction has increased markedly in the recent years. So POM, or production and operation management, requires the cash to pay labor and buy materials from suppliers. So generally, POM spends more cash than any other department in the company. So this is the phase where many big companies fail to forecast changes, and they lose their edge or went bankrupt. Example nito, yung Sony Betamax, yung Blockbuster, Circuit City, Nokia. So each and every one of these situations might have been avoided if forecasting had called attention to the cliff that was in front of their fast moving trajectory. So summary, so strategic planning requires teamwork. So POM should be part of the team. This chapter discussed POM's role in helping to develop strategies and illuminates POMs assigned to carry them out. So POM is responsible for seeking out and adopting best practices. Life cycle stages are also developed. So this includes introduction and growth of new products, followed by their maturation and decline. So production and operation management is expected to protect established products. So the challenge is difficult when competitors introduce disruptive innovations. So recognitions of problems and fast actions to deal with disruptions are needed. Forecasting is essential for proper management of life cycle stages. So extrapolation and correlation are vital method used with time series analysis. Other important forecasting methods that are covered earlier would be or the moving average, weighted moving average, regression analysis, correlation and coefficients of determination, multiple forecasts, and the Delphi method. So also, the means for evaluating the different forecasting methods by comparing the kinds of errors they generate is also covered. And yeah, that's it. That's the end of my report po. Thank you for listening.